Hello Geometry 14.2, practice with pyramids. In this exercise, we're supposed to calculate the volume of each solid and round our answers to the nearest tenth if necessary. So this is just practice calculating volume and using that formula. So for part A, the volume of a pyramid is 1/3 the area of the base times the height. The base is a square, so it's a 2 by 2 square, and the height is 6. So 2 times 2 is 4. 6 divided by 3, that works out nicely, is 2. 2 times 4 is 8. So this would be 8 cubic feet. For part B, we have a cone, and the volume of a cone, the formula is the same. It's 1/3 the area of the base times the height. The base is a circle, so the area of a circle is pi r squared. The radius is 2, so it's pi 2 squared. And the height is 4.2. So 2 squared is 4. So it's going to be 1/3 times pi times 4 times 4.2. And I'm just going to do it in the calculator because I'm not going to multiply by pi in my head. But we have 4 times 4.2 times pi. And we need to divide all of that by 3. And so it's going to be about 17.6, we'll say. And that's cubic feet. For part C, we have a cone again. Excuse me, not a cone, a pyramid again. But it's going to be 1/3 the area of the base times the height. And the base is a triangle. The area of the triangle is 1/2 base times height. The 3 and the 4 are the base and the height. Because they're the ones coming off the right angle. They're not the hypotenuse. The hypotenuse, we'd have to do the Pythagorean theorem to find one of the other legs. So 1/3 the area of the base times the height. The height is 7. So let's see here. Half of 4 is 2. 2 times 3 is 6. So we get 6. A third of 6 is 2. 2 times 7 is 14. So we have a 14 cubic kilometers for this volume here. Last one, we know the height is 12, and the area of the base is 32 square centimeters. The fact that they're giving us the area of the base, we don't even have to find it. That's wonderful. The volume is 1/3 the area of the base times the height because we have a pyramid. Even though it's a 1, 2, 3, 4, 5, 6. Even though it's a hexagon, we know that the area of the base is 32. So it's going to be 1/3 times 32 times the height, which is 12. Let's see. 12 divided by 3 is 4, so I need to do 4 times 32. That's 128. And we're in centimeters, so that's cubic centimeters. So yeah, there's just some practice finding volumes of some cones and pyramids. Number 2, we get a little algebra to do here. A particular cone has a radius r and a height h. Cool. Has a radius r and a height h. So there's our cone. Write an expression for the volume of the cone in terms of r and h. Well, the volume of a cone in general is 1/3 the area of the base times the height. And because the base is a circle, the area of the circle is pi r squared. So the volume is 1/3 the area of the base, which is pi r squared, times the height. And that's it. Part B, what is the height of a cone whose volume is 16 pi cubic units and whose radius is 3? So we're trying to find the height. We know the volume is 16 pi and the height is 3 units. So I'm going to rewrite this formula we have over here highlighted. 1/3 pi r squared h, and just plug in what we know. The volume is 16 times pi, and that's equal to 1/3 pi. The radius is 3. The radius is 3. So pi times the radius, which we just said is 3 squared, times the height. And the height's what I want to know. So here's an equation. It looks nasty, but there's only one letter we have to really solve for. So there's not a ton we have to do. 3 squared is 9. So I'm going to rewrite this as 1/3 pi times 9h. And 9 divided by 3 is 3. So let's come over here. We have 16 pi equals 3 pi h. And I'm just going to divide both sides by 3 pi. The pi's cancel out, the 3's cancel out. That works out nicely. So the height is, well, those pi's cancel out as well, is whatever 16 over 3 is. 16 thirds is, what's that, 15 and a third? That's about 15.3. It's about 15.3. So either one of these is fine for an answer, but here we had to work a little backwards. We know our formula for volume for part A, and then we just had to apply the given information to go work backwards and find out what the height had to be. In part C, this is the last part of this activity here. What's the radius of the cone whose volume is 16 pi and whose height is 3? So this time we're going to be given the height and we're going to look for the radius. So I'm just going to write down what I know. The volume is 16 pi cubic units. The height is 3, and we're trying to find what's the radius. So that's what we're trying to find out. Again, just copy our formula down. It's going to be 1/3 the area of a circle times the height. It's going to give us the volume. And I know that 16 pi is the volume. And that equals 1/3 pi times the radius squared. Which I don't know what the radius is, times the height, which is 3. So just plug in the information I know, and now we got to solve it. So let's see. One thing that happens nicely here is 3 over a third of 3 is 1. The 3 over 3 cancel out or divide out. If I divide both sides by pi, those pi's will go away. So we get 16 equals, all that's left is r squared. And what's squared equals 16? Take the square root of both sides, and you get r equals 4. Anyways, so this is, again, just practice. Here's a formula. Can you apply it? Can you plug numbers in and solve for the missing variable? So it's a lot of Algebra 1 and just applying Algebra 1 with geometry formulas.